my physics friend. Today I'll talk about electrical field. Electrical field. Before I start electrical field, I just want to tell you something. I took this test 2 days ago, but in the exam I answered the part 1 and part B I forgot because I took too much pressure that I have to do good in the exam. Don't do that as like me, because physics think as like a cricket match, and you have to, if it is test match, you have to do every single day perform well. If you do perform well in the first and 2 days, third day if you do bad, that means your result is going to be, everything is going to be changed. And thank you my professor that I emailed him and he gave me the credit for that, and he understands that I know this one and I forgot to do this. But don't do that as like me in the exam. Be careful before you submit your paper that you answer everything is or not, okay? And it's really painful if you know something and if you don't answer, okay? So what happened if you want to find out the electrical field at point X due to the charge Q1, Q2 and Q3? Right now, if you know that if it is a positive charge, electrical field is outward. So look, electrical field is outward. If it is negative field, electrical field is going to towards the negative charge. So electrical field is going to this is my negative charge. So this one is a positive charge, electrical field is going to the outward direction. So right now look, you see this is my E1. Okay, so look, E1, we know the formula for electrical field EQ1, say EQ1, okay, so it's going to be easier. KQ1 R square. KQ1 R square. And our distance we don't know, but we know the from here to there is 4 centimeter, and this point to this point is a 2 centimeter. So we can use the Pythagorean theorem. What is the Pythagorean theorem? R is equal L square plus D square. Root over 4 square plus 2 square is equal to root over 20, 4.457. It's centimeters, so it's centimeter. If you divide it by 100, it would be 0.0. R is equal 0.0447. This is your what? This is our distance R. This one. So K equal, we know 9.0 10 to the power 9, and Q1 is equal, it's given 8.0, but mu coulomb, so we have to convert into the coulomb. It's 10 to the power minus 6, negative 6, minus 6, and its R is, we do know right now what is R. R is 0.0447 square. If you apply them into the calculator, it will become 9.0 10 to the power 9 into 8.0 10 to the power negative 6 divided by 0.0447 square. 3.6 10 to the power 467. I have to see my video is working or not. Yes, it's going on. So 3.6 10 to the power 7 Newton coulomb. But we don't find out yet what our x component and y component. So x component, it would be 3.6 10 to the power 7 cos theta. But theta, we don't know what is going to be the theta. So we have to find out this one. So if you use the formula, theta is equal to 10 inverse minus 1, and opposite upper adjacent, what is our opposite, is going to be 2 centimeter divided by 4 centimeter. Is cancel out. 2 divided by 4 is going to be half, and it comes, if you apply the calculator, 26.5 degree. So this is our angle, 26.5 degree. 3.6 10 to the power 7 cos 26.5, it will give us 3.2 into 10 to the power 7 Newton Coulomb. So look right now, we don't have to find out the y component. Why? Because Q1 charge is plus 8 mu coulomb, and it's negative Q3 is negative, so their sign is opposite, and the electrical field is also going to the opposite direction. For y component is going to the upward direction, this one is going to the downward direction. So it is a vector, and vector, if it is they are going to the opposite direction, they cancel out with each other, and they cancel out, the y component is cancel out, and just only remain what, x component. But their charge is same, so it's going to, that charge is same, so it's going to be the, and direction is going to the x direction, is going to be the same thing for a Q3. 3.2 into 10 to the power 7 Newton Coulomb. What is the total in x component? Is going to be 3.2 into 10 to the power 7 plus 3.2 into 10 to the power 7. It will give us 6.4 into 10 to the power 7. And this is what this is our x component. Q2 is going to be, it's very easy. Why? Because there is no, we don't have to find out any component, and EQ2 is equal KQ R square, Q2 R square. What is 9.0 10 to the power 9, and it's 2, but you have to convert into coulomb. It's 10 to the power minus 6. Sorry for my pronunciation. And R is going to be 2 centimeter. If you convert centimeter to meter, it would be 0.02 square, and it will give us 4.4. 9 into 2.0 10 to the power minus 6 divided by 0.02. 4.5, yes, 4.5 into 10 to the power 7 Newton Coulomb, and this is your our EQ2. So we find out, so it's going to be total electrical field would be, total electrical field at point X, it would be 6.4 into 10 to the power 7 square plus 4.5 into 10 to the power 7 square. It will give us 7.8 into 10 to the power 7 Newton Coulomb, and this is our total electrical field at point X. Right now we have to find out our angle. Theta is equal to tan inverse minus 1, opposite of our adjacent. What is opposite? 4.5, and this 10 to the power 7, 10 to the power 7, so it's going to be cancelled out. You don't have to write. It's 4.5 into 7.8. Sorry, it would be 4.5 divided by 6.4. This is our opposite, our adjacent. But you don't have to write 10 to the power 7 because it's going to be cancelled out automatically. 6.4, 4.5 divided by 6.4, it will give us 35 degree. 35 degree. This is our total electrical field, 7.8 10 to the power 7, and our angle is 35 degree. Right now we have to find out what our potential at point X. Potential is really easy, but I'm the stupid one. I didn't see in the exam. That's potential part B, but don't do that as like me. What are you going to be do for for potential? It's not a vector quantity, it's scalar. Scalars is like add them up or subtract them. So what happened, look right now. Q1, smartest way you can do, Q1 and Q3, their sign is opposite. They cancel out with each other and just only remain Q2. So potential at point X is at point X only K Q2 R. Make sure not R square, it's R. 9.0 10 to the power 9. Q2 is going to be 2.0 10 to the power minus 6 coulomb, and R is 0.02 meter. 9.0 10 to the power 9 into 2.0 10 to the power negative 6 divided by 0.02. It will give us 9.0 10 to the power 5 B. And this is our answer. So hopefully you guys like my videos. If you really like it, don't forget to subscribe and don't forget to share with your friend. And my punishment is, why I don't see part B, this punishment would be I'll make more videos for electrical field and potential, and it will be, I'll make a really hard videos. I'll get the hard question from my professor and I'll make a video. Hopefully see you guys in next videos. Thank you for watching.